Hi, my name is Ryan Navarro and I'm an applications engineer here at Hawk Ridge Systems. This video is going to be a little different. I wanted to talk about an ornament I designed for a design contest we had here at Hawk Ridge Systems. So one of the cool things about working here is every year we participate in contests both internally within our company and from SOLIDWORKS for things like the beta testing of the new release. And then sometimes periodically too, we'll just have little internal contests to keep our design skills sharp. So one we had this year was designing an ornament to be 3D printed. This is going to be a two-part series. So this first video is going to deal with the setup, the concept generation, and just a few key notable steps of the modeling process. It's not going to be a tutorial by any means, but I want to talk you through the process I used to design this and model this and point out a couple of the tricks I used in SOLIDWORKS to do that. And then there'll be a second video that looks at how I validated the design, generated some outputs like photo renders, and show you a peek at the finished result. So let's go ahead and get started going over the design here. I'm just going to roll back through my feature tree and show you how I got started. So I came up with the idea of a bell, and we were given criteria from the beginning, had to fit within a 2-inch bounding box. So I have some different planes offset here that end up being a little under 2 inches from the origin. So one thing I thought would be interesting to really showcase the fact it's 3D printed was to have a shape that would have built-in undercuts that just wouldn't be moldable by any other manufacturing process. And I settled on this shape of kind of the twisted loft, really simple shape there. One little distinction I made is I did 2 separate lofts because I wanted to have the twist to be a little bit variable throughout there, and I wanted from the side for it to look a little bit more of a sharp transition. Whereas, as you know, if we did this in a single loft feature, we would get a much more smooth bell-like shape. And this is going to be a bell that I'm creating here. It's going to be functional with the little clapper inside. But I just didn't want the, too smooth of a shape here. So I split up into 2 loft features. And then we can see if we just roll down, it's just a lot of face fillets and a shell operation. I shelled this out to a 1mm wall thickness. And the HP 3D printer that this was printed on can actually handle even finer walls than that. But I thought that was a good balance. So again, if we look at it from a side view here, we'll see the cross section. We can see that it's a pretty complex profile. Then really, I turned my attention to the mounting arm, or how this would actually be suspended from the hook for the ornament. And this is the shape I ended up with, but to show you how I got there, this is kind of one of the nice things I've learned about working with SOLIDWORKS. In the past, a lot of times I would start out a design and then realize I wanted to change it and basically, delete the whole thing and start over, right? Which, some might say that's the best approach, but when you're just trying to get work done, I try to avoid that as much as possible. So where I'm going with this is sometimes instead of just deleting features and starting over, there's ways you can kind of leave that design history in there. The minor downside is that it might affect rebuild times and file size just a little bit. So if you're interested in the most optimized possible model, yes, you would want to clean out those unused features, but here it allows me to show you what I was thinking as I built this. So initially I had this. I had the mounting arm, kind of a simplest possible mounting arm half model here, just looking at it from above, because I didn't sketch this thing out by hand ahead of time. That's great if you're working from industrial design sketches or something like that. You have an advantage. Here I was just designing as I went. So I got it pretty well defined, and then I'm looking at it and saying, I really it doesn't match the rest of the bell. It doesn't match the ornament. It doesn't really show, nothing about this mounting arm really shows off that it's 3D printed. So I thought, wouldn't it be cool to twist this the same way the bell is twisted, right? And actually, again, just have nothing, basically no straight edges on this thing, no straight lines. So rather than starting all over, I split the part using the split command, and I just moved that moved these bodies with the move copy body commands to the rotation amount that I wanted. So if we scroll down here, we'll just see that we have just moved these bodies to the orientation that I wanted. So again, and I may have lengthened them a little bit. I used some direct editing commands, the move body and move face command, so I could get those into the orientation I want. So I didn't actually sketch anything. I just cut away some of the material, basically split it out, rotated those bodies, and then now I loft that back together. Okay. So now I've created an arm that's twisted at the angles I specified, while preserving my design history, and it's kind of preserving my thought process here, because you can roll back and see, oh, okay, they started off with a straight arm, they got it functional, and then they realized that wasn't really the aesthetic they were after, so they went back in and lofted it. So ultimately, I ended up actually flipping this around at some point to match the twist of the bell ornament. So we can see here, as we add in the eyelet on top, which was provided to us, and I also just mirrored that to reverse the orientation of it. So we get kind of these sweeping lines that match the bell. So this is all fine and great, but we don't have anything to make it an actual bell yet. One of the other aspects of this that I wanted to showcase the fact that it's 3D printed was to have an integral assembly, integral mechanism that wouldn't require any assembly. It would just be an as printed mechanism. So that's what we can see here if we explore the next folder. And I'm a big fan of using folders for organization. Some people might prefer to name features, but I just don't need that level of detail typically, so I just simply group things into folders, and then each folder has a manageable number of features inside that I can roll through. You'll see there might still be some key features that I'm naming, or key sketches that I'm naming, but that's about the level of organization that I like to go to. So again, rolling back a little bit, we can see starting off with the top portion of what will become the clapper, establishing some planes, and then again, this could be a loft here. It's actually a boundary with just a twisted shape once again to represent the clapper there, kind of matching the lines of the bell, and then just applying some fillets to round that out. Now, one of the things you might notice, you look at a swoopy geometry like this, and a lot of our users might think surfacing, right, using the surface modeling commands. But here I've done it entirely with solid features. So it is called SolidWorks. I know it's maybe a little bit cliche to say that, but I always try to default to our solid features, solid loft, solid boundary, unless there's a reason for me to go to surface modeling command. By the way, as far as clearances go, we can investigate that here. I honestly can't remember exactly what I used for clearance. It's like about a 0.5 millimeter of clearance. This printing process does use powder and a resin, so there was the need to blast out with compressed air any residual powder in there. So that's the main reason behind that 0.5 millimeter of clearance. Finally, just to showcase the fact it's 3D printed even more, I just perforated the whole thing. So we have this hole pattern here, again, that's following the shape of the bell. So I wanted a way to have these holes and to be able to adjust the size of them as they flowed up. So I'll show you how I accomplished that. I basically just created a single row of extruded circles, cylinders here. Very simple. And I used the face curve command. So this was the cleverest way I come up with, using the face curve command, Sketch Tools face curve on this here, to generate some vertical UV lines, or I guess longitudinal UV lines that would flow in the direction I wanted. So that's these 3D sketches that you see here. I then used a curve-driven pattern, one for each set of UV lines. to get those bodies moving the way I want. And then I just used move face commands to resize the bodies as I saw fit. So I used move face commands to selectively tweak the size of them, which actually was pretty easy to do. You know, it's not a quick way to do it. So this is the advantage of doing like a Boolean type modeling. Again, working as a solid. At the end of this, I can move those things around where I want them to be. You know, I even tightened up the spacing a little bit of them there with some move, copy, body commands. I patterned those all around, and then ultimately we're just going to Boolean them. So just subtract them from the bell. Again, I really was happy with the results for using that approach. Anytime, you know, you could try to do it with just a regular pattern. I could have tried to do an extruded cut and then just a pattern feature, and I would not have had this ease of manipulation and just the visual in advance of letting me see, you know, okay, let me move those holes down before I merge them together. Again, a lot of this is really particular to aesthetics and just what I thought looked good, but I wanted the flexibility to be able to move things around, and I knew, you know, creating these separate bodies, essentially tool bodies that I'm going to subtract, gave me the most possible flexibility. That concludes the core part modeling portion of this design exercise of mine. Hopefully some of these tips, or just the thought process on how I approach this design, might be helpful to you. So again, this is kind of some insight into the design portion of this, and then we're going to have a second video here that will cover kind of validating the design in terms of the performance of it, producing some outputs. So those would be renders in SOLIDWORKS Visualize and the preparation that went into that, and then also taking a look at the finished result. Thanks again for watching.